Okay, so we are live for another episode of Howdy Partner. My name is Jeong. I am a partner solutions architect here at AWS. Great to have all of you attend today. Good morning, good afternoon, good evening, wherever you are. With me are two fantastic guests, Sean and Jesse. Want to go introduce yourself?
Sure thing. So Sean Pomeroy, solutions engineer at Kubecost. I've been in the cloud space for about 7 years, focusing primarily on cloud cost optimization.
And Jesse Goodyear, also an SE here at Kubecost, formerly of Nginx, but CKA. Been doing Kubernetes for about 2 years now, so learning pretty quickly. Glad to be here.
Sounds good. So before we dive into what you guys will be presenting today, just want to give a little bit introduction for those of you who are joining us for the first time today, or for those of you who have already been with us. AWS Howdy Partner is a show where we, well, as the name suggests, host our partners from the AWS Partner Network. It's a network of partners that help us build and enhance experience on AWS Cloud for the customers that we have. So we want to see all the cool things that our partners have been building, and that's why we have Kubecost with us today. And before we jump into Sean and Jesse and what they are bringing today, just want to kind of set the stage a little bit here. So what are we talking about and why are we really here? So on AWS, if you want to leverage some of these services to build out your containers environment, you can think of things like ECS and EKS. And especially when it comes to EKS, as Kubernetes is fast becoming one of the hottest orchestrators that you can think of when you're running your containers, is this idea of a multi-tenancy or I guess multi-tenancy. I was thinking of some other words, but I think we'll stick with multi-tenancy. Is this idea of hosting or providing a platform for different teams or different tenants, as you may have guessed from the word. And when it comes to multi-tenancy nature of EKS, you really have to think about the cost associated. Well, I mean, there's other things, obviously, but one of the main things we want to think about is cost when it comes to spending. How do you determine, which team or which tenant is spending how much, and kind of gaining that visibility or being able to optimize around that is, I think, increasingly becoming one of the problems that we see with anybody that's using EKS. And you can think of things like cost tagging when it comes to EKS or ECS really, but how do you have visibility into a finer or a more granular level of cost? And kind of going back to multi-tenancy around Kubernetes and EKS, you essentially have tenants built around namespaces, or even at an individual pod. How do you have that idea of how much you're spending or how much your tenant or your team spending? And what I've seen from engaging with our customers is that sometimes they just have no idea, or they're trying to figure out this concept or implementation of how they would think about even looking at costs, because maybe they want to kind of scale out within EKS, but they're kind of afraid. They don't want to, ship things into production and end up with all these, spending that they didn't have any visibility into. So with that, I think that's where Kubecost comes in to solve this problem. But, I don't work there. So I think Jesse and Sean will probably have a better way of explaining what they do exactly and sort of how they implement, or how you could implement visibility using Kubecost and some of the features that they have. So let me pass it over to you guys, and I'll be quiet and take it on from here.
Perfect. Appreciate it, Young. Yeah, I mean, you did a great job explaining it. I mean, cloud costs in general are a big problem, right? I mean, especially at the scale where these large enterprises are operating, even the smaller guys as well. The ability to purchase cloud with a credit card and just kind of go off and do whatever you want is super awesome because it allows us to scale quickly, but it also allows the cost to kind of get out of hand quickly. And the providers have done a really great job, AWS included, in exposing utilities and tools to allow customers to get insights into that cost information, right? The AWS Cost Usage Report, AWS Cost Explorer provides the level of detail, not only to bill the customers, but also give them insights to what the different teams are spending, either if it's based on like a service or even a tag. That's probably the most common in the space. But when you get to Kubernetes, that gets infinitely more complex, right? Because no one's really essentially metering Kubernetes, and because Kubernetes decide to design to scale, right? As workloads come up and come down, as more traffic comes to your applications, it can scale up, it can scale down, it can use more or less resources based on demand. So tracking that usage over time is it's difficult. Right, and that's essentially what gave birth to Kubecost. Some former engineers saw this problem when they were working at Google on the Borg project, and they essentially collaborated together and came up with the concept of Kubecost. Launched a few years ago now, and the idea was exactly around that multi-tenancy, right? As these enterprises build their applications and deploy them to Kubernetes, specifically in a multi-tenanted fashion, they need a way to be able to do show back and charge back, right? What does it cost for this application to run in my production environment, or even across all my environments, right? Production stage or development. So the main intent of Kubecost is to provide not only that insight, so the different teams can get an understanding of what they are spending within EKS and Kubernetes in general, but also to continue that conversation with regards to providing insights into saving money, right? So resizing your workloads to be more efficient from a cost and resource utilization perspective. Go ahead. Yeah.
Yeah, just give an example of like how customers are using Kubecost. And it's not just a typical enterprise where the IT team is deploying their applications and they need to understand how much each application is costing that company. We also have customers that their product is to deploy a container in a namespace per customer. And so when you're trying to do a P&L, profit and loss per customer, and you just see this Kubernetes line item in EKS bill, it doesn't really tell you how much each customer costs. And that's really one of the things that is very valuable for Kubecost.
Cool. Awesome. Yeah, I'd love to start with kind of showing just a little bit of a high level overview of what we can do, and then Jesse's going to dive right into how to deploy the tool within minutes within your cluster to gain those insights. So Young, if you could share my screen. Awesome. So we have a number of ways to expose the data, and in our experience, it kind of depends on who needs access to it, right? A finance person that's building out that P&L or the profit and loss statement, like Jesse was talking about, they're typically going to want to look at like a UI, or they're going to have some type of data stream into like a BI tool, whereas like an engineer developer might be using some command line tools or the API to gain those insights. I'm going to focus on the UI, but then we're also going to kind of talk about those different mediums as well. So just from a high level, the view I'm looking at now, we're trying to keep things simple, but also exposing enough information to make informed decisions. So right now I'm looking at just simply my cost by namespace for month to date spend, right? So we're running within the cluster and consuming the standard Kubernetes metrics to get an idea of what the cost is for a resource based on the CPU and memory that it's consuming within the cluster. Now, the view I'm looking at now is specific to namespace. In our experience, this is the most logical way to separate costs within Kubernetes, especially in a multi-tenant workload. But we also have customers that are doing it based on labels, deployments, basically all those different Kubernetes concepts that might make sense to differentiate the cost by. So we support kind of all those different layers of dimensions. With regards to kind of how we're showing the cost here, we're going to get more in depth later in the stream to kind of get to where we're defining the costs and how they're separated out. But just at a high level, showing my 2 costs here based on 2 different namespaces in one of our demo environments, showing it up over time to kind of show those costs, as well as based on what's in cluster, out of cluster, some shared spend, and then also reporting on how efficiently those resources are consuming the resources within the cluster. Now, for most of the customers and large enterprises, they're going to have more than one cluster, right? So the view I'm looking at now is specific to my namespaces, but I also have the ability to pull up a more dedicated view to my cluster view, right? So think of this as a good way to compare your costs to what you're being charged from the provider, right? So if you were to open up your AWS Cost Explorer, you could essentially look at what am I spending for EKS based on a specific cluster. Similar view here. You can see I've got 3 clusters reporting in. I've got my production cluster, my staging cluster, and my development cluster running across 3 different cloud environments. I can see my total spend from this view. But then I can also click into each cluster individually and see the cost based on those namespaces. Or what I find kind of more important when we're talking about that multi-cluster, that federated view to get like a total cost of ownership across your different Kubernetes clusters, especially if you're using a standard naming convention with regards to namespaces and or labels, is that when I go to my namespace view, I'm now aggregating my costs across clusters. So I can see that, well, my Acme Fitness app, this cost me $178 to date, month to date, to run across all of my different environments. But if I also wanted just to filter that down, just to understand what it costs me to run in my production environment, I can still add a filter and just look at those costs specific to whatever cluster that I want. Talking a little bit about how we get our costs. So I mentioned that we're consuming the standard Kubernetes metrics resources. So we're using kubestate metrics, container advisor, node exporter, and we also have a network metric component. Those are all stored in Prometheus. So we come bundled with Prometheus as part of our Helm chart. We can also work with your existing Prometheus deployment. Additionally, we're consuming the Kubernetes API. So we're getting metadata about the workloads, specifically how long containers are running within a cluster. And then finally, the cloud provider cost information, right? So obviously, you can't determine cost without having a baseline to start at. So we're collecting on-demand rates from the AWS pricing API. And then you also have the ability to hook up your cost and usage report so that we can more accurately reflect pricing based on enterprise discount programs, spot usage, reservations, savings plans, all those different constructs that AWS provides to give you some savings within the cloud environment. Based on all those different metric sources that we're consuming, Kubecost then does some calculations and we allocate the costs based on that metadata within the cluster, as well as a combination of the requests and usage for CPU and memory for the different workloads running within the cluster. And then we essentially emit those metrics to Prometheus as well. All right. And as part of that, I think Jesse's now ready to run through what an install would look like. Is that right, Jesse?
Yep. Yeah. Jeong, if you want to switch the presentation over to Jesse.
Let's see. I think your screen went off.
Okay, I'm sorry about that. I will quickly share again.
Yep, no worries. This is part of a live show, so
There we go.
there we go.
Luckily, we know how to share it
Perfect.
in these day and age. All right, so as Sean said, we're going to do a quick install of Kubecost, just the basics, and then we'll get into more detail as to what you would need to do in an enterprise environment. What I'm showing you right now is our kubecost.com, and if we click on Get Started, you can fill in your email address, and it will print out this command that we can then run against an EKS cluster, any cluster, Kubernetes, on-prem, OpenShift, doesn't matter, right? This is all just standard Kubernetes stuff. I'm in this cluster called Jesse EKS4. If I were to paste this in, hit enter, it will go in, add our Helm repo to your client, and then install the chart from the sources. We can get into more detail on Helm as we go along here, but it's a great tool for managing your Kubernetes deployments. Really simplifies showing what values are required for particular software that needs to be deployed to your cluster. And so let's get into that right now. So while this is working, I'm going to switch to a different cluster that's already working. If I were to just switch to this namespace and show you that we are progressing with our deployments, and hopefully the text is big enough here, otherwise I can increase the size. And actually everything's already up and running, but there's no data there. It takes us time to collect from various sources, and then we actual see activity of the containers so that we can put them in the database and then show them in the graphs that Sean had up earlier. So if I'm going to switch just to another EKS cluster, excuse me. And you can see we've got all the Kubecost deployments running, a couple daemon sets for the node exporter and our metrics collections. Anyway, that's all handled by the Helm installation. The next thing we'll talk about is customization of Kubecost. And so one of the things that you won't get if you just do the installation like I did from just the basic Helm install Kubecost is to get integrated with the cloud provider. And so we don't have, Kubecost is completely read-only, but we don't have access to the AWS APIs to get the billing data. We don't have access to get the cost and usage report. And so those are service accounts that Kubecost needs in order to give you more accurate data when you're looking into the costs here. And so what does that look like? Well, at the very basics, we have a couple of files that we walk through how to provision the cost and usage report, the bare minimum permission sets that we need in order to view that. And it's all in our documentation. I'm not going to go through that right now. You can see there's a bunch of values here that are very common, like what's your project ID, what's the name of the service account, what's the service key for that service account, things like that. And so at the end of it, we will have a very lightweight values file that will tell Kubecost where those accounts are and how to access it. And this is all you would need in order for us to reach out to the cost and usage report and reconcile the actual costs with what we've estimated to that point. So Sean mentioned earlier, we're trying to give you the most accurate cost possible. In the short window, where we haven't got a cost and usage report, we're doing estimates. And after those estimates are done, we'll give you actuals. Let's see. We didn't talk about the architecture that much yet. Sean, I'm going to jump into that unless you prefer a different method.
Yeah, no, that's good.
Okay. So in our enterprise architecture here, we have a primary cluster that has the UI that Sean was showing earlier that does all of the displays to the end user, as well as an API. And so the API is, we're an API first product. Everything you see within the GUI is available to a programmatic access in the backend if you want to pull it out and put it into some business intelligence utility. Anyway, so that's the primary cluster. In the case where you've got multiple clusters, then they need to be able to communicate. The way that Kubecost does that is via a shared S3 bucket. Right? This could be anything that's compatible with Thanos, but S3 compatible storage bucket is what you need. So what happens with your additional clusters is we install a lightweight Kubecost deployment that all it does is look for the metrics of the containers, pods running on those other clusters and sends its data back to this shared bucket. We don't have any direct access from these secondary clusters. Matter of fact, all of Kubecost is hosted on your own clusters. right? So there's no data coming back to us. There's no data going to Amazon, right, or AWS. It's all on your own clusters. Now we'll have the SaaS model in the future. If that's interesting to you, let us know. But for now, this is our standard deployment model. So the primary Kubecost cluster does a few things. Obviously it monitors its own cluster, and so it's got that metrics gathering that's sending its own data to that bucket. But it also has some jobs that run in order to efficiently display the data. So we do some caching based on the data that we're pulling out of the bucket, as well as doing the cost reconciliation with the cloud providers. So now I'm going to switch back over to how do you install a primary cluster, and how does that differ from these secondary clusters? So going back to Visual Studio Code, our tool of choice, the primary cluster is kind of what I was showing you earlier, just base set of values. The secondary clusters, the main thing that changes is everyone would need their own unique cluster ID. You could use what AWS assigns in their EKS clusters, or you could provide a friendly name that users within your finance department may find more friendly. And in this one, we're disabling a few features in the Helm chart that aren't needed on the secondary clusters. For example, we ship with Grafana so that you can create your own dashboards, but you wouldn't need that at all on a secondary cluster. Matter of fact, if you're not going to use Grafana on your primary clusters, you could disable that, right? It isn't a dependency of Kubecost. It's just something provided to you in order so you can create your own dashboards. Anyway, so run these Helm installs against all of your clusters. They aggregate back to that shared storage bucket. Once we've done that, then we can start looking at the data. And so I mentioned earlier that there is a API that drives all the data. And we also have a tool we wrote in Crew. It's a add-on manager for kubectl. And if you haven't heard of it, it's very straightforward. We can send a link to that earlier. But so when we're on a cluster, we can just use kubectl cost and then namespace, and from the command line, find the costs associated with all the namespaces running on that cluster. You can see in this demo cluster, we've got two namespaces, kubesystem and kubecost, the most important namespaces of all, and the total costs that would be over the month. A couple different ways we can run this report. And so the current one is to show what namespaces are out there, and based on the monthly rate, what that would cost. Or we could show actual totals based on the past day and see what those are. You can see we're trying to be very efficient, so we've got a small cluster here, and so it's only been 80 cents of costs in the past day for this particular one. Matter of fact, I probably only ran it for 6 or 8 hours so far today, so that's why it's so cheap. But anyway, you give developers easy access to understand what it is that's driving their costs, and that may be one actual CPU utilization, or it could be what they've requested. There's Sean will get into much more depth on the efficiency thing later, but it's when the developer that deployed this resource asks for all these reservations, which Kubernetes calls requests, and they're not using them. And so we give insights into that as well. From a standard JSON return API perspective, I have a couple different commands to show you. First is around the savings. And so, I just showed costs in the previous example. Another thing that Kubecost does really nicely is give you ideas for how you might save costs within your clusters, because we've got all this visibility into it. And as Sean said, we've got software engineers that came from Google, and they have a very good idea of what is an abandoned workload, right? So in the Kubecost world, we're looking at if this container hasn't seen any network traffic over a period of time, there's a good chance that it's abandoned and no longer providing value in that cluster. Same thing with resizing your clusters or resizing the requests on your containers. We can get much more sophisticated, or we can dig into each one of these via the command line as well. And so this may be an interesting thing to show inside of your business intelligence dashboards, or we might want to dig into, hey, what are those actual pods, and can we create a report and send that to someone? And so the answer is there's an easier way to do that in the Kubecost UI. Sean will show that in a minute. But if you wanted to get any of this information via CLI, it's here. And for those of you that know JQ and JSON parsing, you'll have a fun time with it. For others, I think the GUI is probably a little easier for most of us. So with that, I will turn it back over to Sean.
Cool. Thanks, Jesse. And I did see a comment in the chat from Gifted Greedy about not really a question, but he's wondering, how AI can be used within this scope. That's actually really interesting concept. We're not using anything with AI today, but I can certainly see some use cases around projecting what efficiency would look like based on perceived traffic over like historical period of time. So maybe you get to the point where you're like dynamically updating requests based on historical traffic you've seen using some type of machine learning to predict that out in the future. I'm sure there's a number of other different ways to do that, but that would definitely be an interesting conversation to have. Awesome.
Perhaps you're releasing your future works here.
Hey, maybe, right?
Business idea.
Good thing it's recorded, right? Awesome. Jeong, if you could share my screen again. Awesome, thank you. Yeah, so I'm going to get a little bit more technical and kind of dive into how we're actually determining the cost for the workloads. If you have any questions, feel free to throw them in the chat there. But thanks, Jesse, for showing how easy it is to install. Unfortunately for the technical folk out there, we're not going to be spending a ton of time at the command line because the tool itself really is that easy to deploy. Very straightforward. Although for the more complicated environments, we do have a very robust Helm chart with a lot of really different examples based on the different environments we see. So, if you already have, a Prometheus deployment, we can obviously reuse that. Same with Grafana, same with your node exporter and kubestate metrics. We realize that a lot of the companies leveraging Kubernetes already have like these best practice tools in place. So we want to make sure that we can adapt to consume those existing sources of information. So we do have a Helm chart repo that you can check those values out as well as a really robust documentation site, all freely available to reference. With regards to how we're determining the costs, you've noticed, obviously there's a lot of numbers on the screen. We're trying to give full visibility, and we fully recognize that, different personas may not necessarily be interested in all the details here, but we're kind of erring on the side of the information that we have as opposed to limiting what you can see and get to. There's really a few different categories of costs. And before I get into that, I kind of want to talk about how we actually determine the cost of the resources running within Kubernetes, basically our secret sauce, right? So operating at the namespace level, I can fully drill down through the Kubernetes hierarchy. So from namespace, I'm now looking at all different controllers within, so your deployments, your daemon sets, your replica sets. If I go ahead and pick a particular deployment here, you'll see it now operating at the pod level, so I can see all the pods running within that particular deployment. And then finally, once I click on the pod, now I'm looking at the actual containers that pod is composed of, right? In this case, we've only got a single one. I'm using, VMware's open source Acme Fitness demo application. And this particular deployment has a single front-end container running within it. So even though in Kubernetes itself, you're not really interacting with containers, you're interacting with, at a minimum, the pod level, we are actually calculating our costs at the container level because those are the actual resources that are consuming the CPU and memory cycles within the cluster. So we're using 3 different sources of information to get to that total cost. The first is that Kubernetes scheduling API, right? So how long has a container been running over a period of time, right? In this case, we're looking month to date. In this case, this particular front-end container has been running for 306.33 hours. The next is the pricing information, right? How much does a node cost and how do we break that down based on the CPU and memory within that node? And then finally, we're using the metrics that we're consuming, right? So how much CPU is it consuming, how much memory is it consuming. Now that last part is really important because there's a few different ways you can look at that information. Specifically with the way that Kubernetes operates, and Jesse touched on this with regards to requests, that's really best practice, right? When you deploy within Kubernetes, you should really be setting requests at your pods, right? So how much memory, how much CPU is this particular application going to need? And then when you're talking about new applications, greenfield applications, typically the developer is not going to know. So we'll typically see over provisioning, right? So say, well, I need 4 full cores and I need 26 gigs of RAM, but in the end they consume much less than that. So what we're actually doing is we're looking at the usage, the actual consumed usage, and comparing it to the request size. And then we're going to calculate the cost based on the higher of those two values. So in the example of an over-provisioned application that's consuming a fraction of what it requested, we're going to charge for the requested capacity, right? Because Kubernetes is essentially scheduling resources based on the capacity that's requested to ensure that those applications can run. On the flip side of the equation, say maybe something's a bit under provisioned. Now it's consuming above the resources that it has requested. Now we're going to flip to calculating the cost based on the actual consumption. So always the higher the two values with regards to CPU and memory. For things like storage and load balancer and network costs, those are always going to be calculated based on the actual consumption because you're not really reserving capacity in that regard. So based on that equation, that's how we're getting to this front-end container has cost $3.45 for the month-to-date spend. And then essentially calculating at the container level, as you can imagine, those costs all flow up, right? So the cost of a pod is the sum of all the containers running within. The cost of a deployment is the sum of all the pods running within, so on and so forth. And that's how we're able to show you costs at every level, right? Do a quick slide I can show based on that request versus usage. We refer to it as allocation, right? So allocation can essentially be what's requested versus what's used and take into consideration the higher of those two values. All right. So now that we know the costs, we can flow back up through the Kubernetes hierarchy and essentially end up where we want to do, our show back and charge back from. Now, with regards to the different columns, you know how we calculate CPU and memory now. We're also going to be calculating GPU. So if you're running, instances that do expose a GPU and you're consuming that, we do have the metrics that we're collecting and we know the cost for those. So we can tell you what it costs for a particular application to consume those GPU cycles. Storage, your PVs that are attached. Network, so we do have a data set that can run within your cluster to determine the actual cost for network traffic. So that's not just in general network traffic, that's also based on inter-zone, inter-region, as well as internet-based traffic. So obviously AWS is charging based on the ultimate destination for that traffic. So we get that information from the bill as well, so we can show you the accurate representation of what it costs for that application to consume those network cycles. And then load balancers as well. So if you're provisioning, you've got the provider in your cluster to provision your load balancers within AWS, we're going to capture those costs here as well. So we call that those first 6 columns, that's basically your in-cluster spend. Those are the resources that are being consumed by the resources running within the cluster. The next is your external spend. So we usually refer to this as out of cluster spend. This is unique in that you can, because we're ingesting that cost and usage report from AWS, if you're tagging your resources, let's say you've got an application running with an EKS that consumes an RDS database to store some state information, and maybe you're uploading images or videos to S3 as part of your offering. You can actually tag those resources in AWS. They get enabled as cost allocation tags on the cost and usage report. And then when we ingest those, let's say you tag it with, namespace equals Kubecost, we can now allocate those out of cluster costs back to Kubernetes concepts, whether it be at the namespace level, at the cluster level, or even down to like the pod or container level as well. So we can actually inspect those costs from the submenu over here. So I can look at my external costs, and we can see that this Kubecost namespace is actually consuming some S3. We've got some Google Cloud SQL in here, as well as some Azure storage, right? So all the different resources we're consuming across those different providers. And then the last column is shared. So this is especially important for a multi-tenant cluster that has shared services running with it. We have a few different concepts for shared costs. The first is shared overhead. This is great for when you have like an SRE team or like an operations team that essentially manages the running cluster. Obviously they have a cost for consuming and maintaining that cluster. So you can add a fixed monthly fee on top of the actual consumption within the cluster, and then Kubecost will take that fixed fee and then will proportionally distribute that cost amongst the different aggregations within the cluster. Now, what I mean by proportional is that we're going to do it based on actual consumption. So if namespace A is responsible for 20% of the in-cluster cost and usage, then that namespace is also going to be footing 20% of that shared overhead bill. The next is shared tenancy costs, right? It costs money to run EKS on top of the actual EC2 instances that are provisioned. So for AWS managing, the control plane for you, there's a cost for that. So you can choose to essentially share that tenancy cost back to the different tenants within the cluster. And then finally, shared namespaces and labels. This is what I mean by when I say shared resources running within the cluster. So think of a situation where you've got, even Kube system is a great example, right? The underlying compute that manages the cluster, but things like observability and monitoring, maybe security like Istio or something like that. All those different services that the different tenants are consuming as being part of that cluster. You can define that based on a namespace or label or a combination of the two, and we do support a comma separated list here, so you can supply multiple namespaces and multiple labels. And then we'll take the calculated in-cluster spend for those resources, and then do that same proportional redistribution of that spend to the different tenants within the cluster. Now, proportional split is the default, but we do also support an even split if you prefer like an even peanut butter spread of those costs amongst the different tenants. All right. So that's essentially how we get to the cost distribution here. As Jesse was saying, a number of different ways to consume the information. One additional way on top of, with kubectl or the API or the UIs, we do have just a simple export to CSV as well. For those that still live and breathe in Excel, this may be the easiest way to bring that information into the existing reports and dashboards that they're compiling within those spreadsheet type programs. Cool. Do support some filtering. I know I showed that earlier on. So as different people access the platform, maybe an engineer logs in and they want to see details about their app. We do support role-based access control. So as a person uses like single sign-on to log in, maybe they're a member of a specific engineering or application group within their identity provider. We can filter what they have visibility into the tool based on that group membership. So if you want to expose, a handful of namespaces or maybe applications based on labels or even clusters, you can define essentially who has access to what. But you can also filter directly at the cost allocation view. So if I want to look for what a particular application costs, I can filter based on my namespace, my label, my service, my controller, or even down to the pod level as well. And then there's additional customizations here for additional shared costs. So the shared costs I showed you previously were like at the cluster level, but you also have the ability to define like ad hoc shared costs as well. So if you want to kind of change up your model over time, you can easily do that from this view. And what's really nice is that once you do make these configuration changes, you do have the ability to save your report. So like this one's already saved. So let's say I add an additional filter here based on like my KC demo prod cluster. So now I can save this report. I can call this my total cost for KC demo prod, and now I have an easy way to reference those same filters and modifications that I've made. And plus I can also share this report with any additional users that want the same insights that I've curated in this view. Jesse talked briefly about cost savings. Cost allocation is far and wide the most common use case that we hear when talking to different customers about getting some additional insights within Kubernetes. Followed very closely by well, now that I know what I'm spending, what it costs to run my applications, what can I do about it, right? It's the same story as cloud cost optimization. There's a lot of waste in cloud in general, especially when you get to something like EKS. Going back to that same situation I proposed earlier. Brand new application. There's no insight into what it's actually going to cost or what resources are going to be required to support that application. So 9 times out of 10, the application is over provisioned out of the gate, with the expectation that as the application grows, as it runs, as it gets consumed, there'll be an exercise to go back and look at the actual consumption, and then resize the requested CPU memory based on what the actual perceived consumption is. Our aim is to make that a little bit easier. Today, we're operating in a read-only state, like Jesse said, but we do have some plans to add some automation here, hopefully coming in the next release or two. But for the purpose of what we're talking about today, think of this as just a report that's providing the necessary insight and feedback to make those changes to those requests. So based on the resources that we're consuming, those different metric sources, we're operating at the container level here. So we're seeing all these different containers that are running within the cluster, same ability to support the filtering and stuff that we did previously. But we can come in here, we can look at a resource and say like, oh, well, kubeproxy has run 3 different instances over the last 2 days. I think I had selected above. And we can see that over those last few days, I'm consuming a fraction of the requested capacity, right? I'm looking for 100 mil CPU, but I'm only consuming 0.3, 0.2. You'll notice that of those 3 different deployments, the maximum I'm seeing is 0.3. So we're basing our calculation off the actual peak usage that we've seen over that period of time. So essentially that's the ceiling of usage. So based on this, we're actually recommending that you downsize the requested capacity for CPU from 100 mil CPU down to 10 mil CPU. We're always going to leave some overhead, right? Especially in Kubernetes, you want to have some room to breathe with regards to scaling, just so you can cover any spikes and you don't get evicted from the cluster based on that traffic. Doing the same operation for memory, you may have noticed these little yellow triangles on this view. That's a quick visual indicator that you are under provisioned, right? So that could either mean that you're consuming, above the requested capacity, or you don't have requests set. Most of the time, I'm happy to report that a lot of the customers that we're talking to do have some governance in place around deployments in order to encourage requests being set. But it is also very common to hear that, oh, we just deploy with no request, let the application run with kind of whatever it needs. That's not really best practices for running within Kubernetes. So we'll highlight that quickly with that visual indicator, thinking that like, hey, that's the low-lying fruit. You should look at that first and fix that, and then worry about the other things later. So we're doing that same operation for memory. So sticking with the kubeproxy example, you can see that we don't have requests set, obviously system process, so maybe not a great example. But of the 26 megs that were requested, we're only consuming, of the 0 bytes that were requested, we're consuming 17.4 megs. So we're actually upsizing the request size, right, from that under provision stance. And then, of course, we're going to highlight the savings, right? What are the potential savings that you can realize by making this change? And realize that this is at the container level, right? So $4, $5, $7 might not seem like much, but at scale, like in a cluster with hundreds, if not thousands of containers, that adds up really quickly. And as Jesse was also stating earlier, everything is programmatically accessible. I'm sure your mind can wander a bit in what's possible here. But we have some integrations today with like Spinnaker, so you can essentially automatically or dynamically set the request at deployment time, based on the historical usage that we see. but you can also, imagine like, in a CI/CD pipeline with this programmatic access, you can add, an additional check to like your pull request, right? Is the application developer requesting, a decent size of CPU and memory capacity based on, what Kubecost has seen over time, or, going to the fully automated route and dynamically setting them based on these recommendations. One of the things I alluded to is the ability to take action from here. So we are working on a feature that will essentially allow Kubecost to resize these workloads for you based on that historical usage and the recommendation that we're making. Okay. I'm going to pause there for a second. Jeong, do we have any questions in the chat we want to answer?
I don't see any, but I have a question. So I
Sure.
guess going in the route of integrations, what sort of things can customers do with this information? I mean, some of the things I could think of, like if an enterprise already have some sort of an alerting mechanism in place, is that a possible integration? And I'm just trying to think of others that just won't come up in my head for some reason, but I'm sure as an enterprise you have certain tools that are already in place. Where does Kubecost fit within that ecosystem?
Yeah, it's a great question. So there's a number of possible integration points I can think of, from like a reporting capacity where you're essentially pulling this information out and then making it available within, some dashboard, something like, a business intelligence tool to surface that information to the different teams or even leadership to tell, how efficiently we are running at scale, to kind of those automated operations, right? Using this information to make, informed decisions, right? The whole data-driven model to resize your containers, and we're going to show you here in a few minutes. We go up from the cluster, up from the resource within the cluster from there, right? Starting at the container level, going up to the pod level, the node level, and then the cluster as a whole.
That was good. Before you go on, those of us joining now, or slightly before, we're currently on a episode of Howdy Partner, highlighting what Kubecost has been doing for the past few years. I don't actually know exactly, so apologies there. But Sean and Jesse are showing, basically how do you get your Kubecost installed using Helm, sort of single clusters versus multiple clusters, customized values using values.yaml file. And then Sean was just kind of going over the different features, or I guess features of Kubecost, including cost breakdown, recommendations, as well as what he's about to show us. So back to you.
Perfect. Thanks, Jeong. Yeah, and on your last point about
one more thing.
Sure.
If you have any questions, feel free to drop it in the chat. We'll address those. But from the looks of it, you guys are doing so well that we're not getting any questions. So let's just go with that, and I'll pass it back to you.
Awesome. Sounds good. Thanks, Jeong. Yeah, I mean, kind of just continuing that topic for a second here on potential integration points, because we are essentially using, Prometheus as our backend database, right? You can use something like Alert Manager or Grafana to essentially take that information and use it in a number of different ways, right? Whether it be alerting to specific situations or bringing cost information into like existing operational dashboards that your SREs and different teams might be using. Continuing the theme of cost savings, I usually like to say that right sizing or getting recommendations for a Kubernetes cluster starts from like the bottom up, right? So we talked about right sizing your containers, right? So essentially the smallest piece running within the cluster. The expectation here is that you're not actually going to get a lot of cost savings you're not going to get any cost savings from right sizing your containers, right? Because now what's actually going to happen is you're going to get idle capacity. So essentially idle is the difference between what's allocated, right? And remember, that means what's either being consumed or requested, and the actual provisioned capacity of the cluster, right? So as you right size your containers, now your allocation is actually going to go down and your idle capacity is going to go way up, obviously, unless you're provisioning additional workloads to the cluster. Right. And we do show that idle capacity here, backpedaling a bit because I failed to mention that previously. So idle is a huge part of Kubernetes, right? Because you're always going to have idle capacity, right? You're never going to be running at 100% efficiency because you need room and the ability to scale. So you may not see any notion of idle in my view right now, and that's because I'm sharing it. So I'm taking that same shared proportional model where essentially all my tenants are now paying for that idle capacity, even though they're not technically using it. If I don't care, if I don't want the different teams to pay for the idle capacity, I can separate it, right? So I can see essentially from a total picture of my cluster, from the size of it, I can see what that idle capacity is here, right? Just about a little bit under half in this example, but it's there, right? And then I am paying for it, and that's essentially what this efficiency number is indicating as well. Efficiency is our measure of how efficiently a workload is consuming its requested resources, right? So again, you're probably not going to want to see 100 for a production-based workload. We typically aim for somewhere between like 60, 65, 70, 75%. In prod. For something like dev, you can aim, a bit higher, right? You don't need to worry as much about evicting or running out of memory in a development type environment. But essentially, we're keying off that idle and those resource requests to determine how efficiently a workload is running, and that's basically what our savings opportunities are based off of, right? So resizing containers, we've got more idle capacity now. My next step, and Jesse talked about this when he was showing the different API calls, is abandoned workloads, right? So this is, as far as more, something pretty unique to us in that we're looking at the network traffic, so in and out of a pod over a period of time, and then essentially based on that traffic threshold that we're defining here, we're saying that if it falls below that traffic threshold over the past period of time, that we're essentially flagging that workload as abandoned, right? Nobody is consuming it if there's no network traffic flowing in or out, right? That's probably covers 95% of use cases. There may be a need for an application running within Kubernetes to not consume network, but for the most part, they all are, right? This is especially interesting in like development or sandbox environments, right? I'm sure anyone that's listening in can give a number of different examples how they deployed some new cool open source software to Kubernetes, and then they got pulled into a production outage, or there's some type of escalation, or they just forgot about that workload, right? It continues to run, it continues to just consume those resources within the cluster, but it's got no real value. So that's the idea behind this report. And as you can imagine, as you eliminate these abandoned workloads, that idle value is continuing to go up, right? So you can probably guess the next step in this process is to right size your cluster nodes, right? So now that everything running within the cluster is sized appropriately, now that we've eliminated the wasteful spend from those abandoned workloads, now we can actually look to realize those savings by essentially downsizing or adjusting the size of our cluster. And that can happen in a few different ways. Number one, right, like just downsize how many nodes you have, right? If you're using auto scaling, that may happen for you automatically. But if you're using something like EKS or managing your nodes manually, we can highlight some potential opportunities here based on two different recommendations. So simple is going to be like you got a node group, it's got n type of this node. Or complex. So complex, we're going to aim to more tightly pack those containers, pods, those applications into different size instance nodes, right? So based on the memory CPU requirements that they have, we're going to recommend multiple node groups of different size to get that more tightly packing in here. And then of course, we're going to highlight what the potential savings could be by making this move. And then finally, in kind of the right sizing journey for a particular cluster, you can look to purchase reservations, right? RI savings plans tied to a commit, what have you. So then based on the consumption that we're seeing, we're going to surface up those potential opportunities for purchasing RIs to get some savings based on your usage. We do highlight a number of different reports here. I don't want to go into detail on all of them. I'm just kind of touching on what I feel are kind of the most important based on what we're talking to customers about. But I mean, we're going to look for unassigned resources, right? There was a period of time where unattached volumes were by far and wide the lowest hanging fruit in like the cloud cost optimization journey. So we're going to highlight things like that. We're going to look for unclaimed volumes, right? So volumes that are not being used that you could potentially move to a cheaper storage medium. And then we're also going to look for resizing disks, right? So disk with low utilization. Next time you turn a node down, maybe you want to resize that disk to a different type or different size to regain back some savings there. The last thing I do want to highlight here is our spot readiness guide. So one of our engineers spent a ton of time kind of talking to what spot is. For those that don't know, spot is essentially a more ephemeral type workload. If AWS has a ton of capacity in a region that's not being consumed, and Jeong, please correct me here if I'm off base, they'll essentially advertise it at a huge discount to try to get people to actually pay for those resources that are just standing around. The problem with that is the workload really needs to be spot ready, right? The application needs to be designed to run on a workload that can literally just disappear in an instant. So that's kind of the idea behind what we call our spot commander. So we're going to do basically one of two things. Number one, we're going to look for resources running in the cluster today that would be a good fit as is for Spot. So looking at their overall readiness based on the controller type, if they do support replicas, if they're consuming local storage, if they have deployment rolling updates. And then number two, using that same information, highlighting what changes could be made to those existing workloads to make them more capable to run on those spot-based or those more ephemeral-based workloads. All right. So pause there one more time. Let that soak into the audience for a minute here. Let's see if we got, see, Gifted Greedies seems to be loving what's going on, especially the feedback for your questions there, Jeong.
Yeah, there was if you want to speak to the free version, I mean, we want everyone to understand what Kubecost can do for you. And so that's why it's out there. You want to give any more details on like the model here?
Yeah, so open core project, right? So obviously we have a commercial offering. It's probably one of the main reasons we're on one call here, right? But we are based in open core, so we do have an open source piece of software that you can freely deploy and use within your cluster, any number of clusters, any size. That currently today is just like a simple pod-based deployment, so it doesn't come bundled with Prometheus and Grafana, Node Explorer, all those different dependencies via Helm. The expectation is you already have those things, or you're deploying them separately. The open source version does not have the cost savings insights. That's purely based on cost allocation, so visibility into what your spend is within the cluster. Then from like a commercial standpoint, so our commercial product is open core, so we are consuming that open source container. The free version today is limited to a single cluster, but that cluster can be as large as you want, and it can also get everything we're talking about today. So you can hook up your AWS cost and usage report to get accurate information about the actual cost, and you can also get these cost savings insights to see how you can resize your workloads in that environment. If you need support for multiple clusters or longer retention times, that's where essentially the paid offerings come into play.
Yeah, awesome. Thanks, Sean. And I'll say there's one comment about whether or not EKS is in the AWS free tier or not. I'll say that you can run Kubecost on a standalone kind cluster. Any Kubernetes cluster you've got access to, a single node cluster on your laptop works just fine. When you're not in a cloud, obviously there's no cloud API for us to query for what the cost of a CPU hour is or cost of a gigabyte of memory. And so we have the ability, and so that would be the same as if you were an on-prem customer. You've got VMware, you've got OpenShift running on 180 nodes, whatever it is. We've got customers that are 100% on-prem at this point. And what they do is they provide a pricing file to Kubecost so that we can then allocate those costs back to their customers or to their clients. And so we can mix and match cloud environments, and we can mix and match on-prem and cloud. So both of those exist. If you want to just try Kubecost to see what it does, like I said, you don't need to necessarily run it on a cloud provided cluster.
Yeah, excellent point, Jesse.
And
Thanks for that.
just to add to that, Kubecost also provides support for EKS Anywhere. So if that is your choice of on-prem deployment option for EKS, know that you can always leverage Kubecost to extend, kind of completes this picture of hybrid model, which seems to be a popular thing going on these days. So just wanted to drop that in there.
Yeah, and I think to that point, I think we actually also have like examples in our docs on running on like Minikube, right? So if you want to run something like locally just to check it out, that's fully supported as well. And we actually fully support air-gapped environments too. So for those more sensitive environments, we can run fully disconnected from the internet as well.
And Sean, next on the agenda was either talking about alerts and SAML, which I'm happy to do as well. I'll give you a break, or you can continue on, whatever you choose.
Yeah, let me touch on alerts real quick, and then if you want to dive into SAML, I'm sure the audience would appreciate that. That's essentially what we consider like your stage 3, your day 2, right? Is that now that you are doing cost allocation, you're right sizing your environment, getting those cost savings insights. What do we do about governance, right? How do we become aware of these situations ahead of time? So we've got a number of different alerts that we support today. Again, if you guys are already using Alert Manager or some other tool that consumes those Prometheus metrics, obviously you can use that as well. And then for the alerts, we're going to support essentially 2 channels of communication, so just standard email, as well as a Slack webhook. So a few different ways to get the information there. Recurring alert, I refer to this as a scheduled report. So basically what this is doing is you define a period of time as well as an aggregation or any filter. So let's say I want to get my cost for my namespaces over the last 7 days. I can define an alert for that threshold here, and then I'll get that in my inbox or via Slack, once a week to get a simple overview of what the costs are based on namespaces. The next is efficiency, so keying off that efficiency value, right? And that again is how efficiently a workload is consuming its requested resources. You can define a efficiency threshold, and then if a particular workload drops below that threshold, we'll send a notification. And then additionally, you can define a spend threshold, right? So if the threshold is only going to be like $5 and you don't care about that, maybe you want it to be $100 or more, we'll make sure that you only get a notification for those more high valued workloads. Budget-based notifications, perfect for showback, chargeback, for different teams that are concerned about, exceeding what their budget is for a period of time. You can define that threshold based on, namespace, pod, application label, and then get a notification when that budget is exceeded. And then finally, spend change, or this is more like cost anomaly detection. So based on a historical moving average, if the spend increases or decreases based on that relative threshold, to get a notification about that as well. We'll also do cluster health notifications. So because we are running within the cluster, we're going to calculate what we're calling a cluster score. So basically on a number of checks or health checks that we're doing, if that cluster score delta changes past a certain threshold, you get a notification. And then also just Kubecost diagnostic notification. So if there's something failing within Kubecost itself, you can get a notification for that as well.
Yeah, I think this piece that you just went over is very crucial, because I talked to some customers, and in the beginning we talked about, how do I get visibility? It actually all leads to kind of the chargeback idea, or the idea of a chargeback. How do we manage, you get visibility into your clusters or what's going on, but what do you do with that data? How do you plan for things financially? So I think this is a really critical piece of kind of, completing that puzzle, so to speak.
Yeah, makes
So
sense.
very cool to see all of this.
Awesome. All right, Jesse, you wanna do some SAML?
Sure. I mean, I can. I might as well. We'll talk through it, and then maybe we'll get into a demo too. So, Young, if you wanted to switch back to my display, thank you. All right. So, Kubecost supports SAML authentication, and so if you've got Azure AD, Okta, Ping, whatever SAML providers that are out there, we can integrate with them. So you don't have to have a single, or you don't have to have another username and password to Kubecost. Matter of fact, we don't support username and passwords. If you don't do the SAML integration, everyone who logs into Kubecost gets to full access, essentially. You can see whatever is going on in the inside of Kubecost. So for larger customers of ours, we've given them the ability to, one, narrow down who can log in. And then number two, if they have read-write, as in admin access, or read-only. And so both of those are independent of the next thing, which is filtering. So filtering is an ability to say this group of users can only see these namespaces. And what I'm showing you on the screen right now, you can see kind of the syntax here, where on the top, the administrators have full access to all namespaces and all clusters, whereas this Kubecost team 1, and the prefix here is kind of a construct inside of the identity provider. So when you're creating new groups, you know that this group was created simply for the ability of Kubecost to do the filtering based on that group name. And so having the prefix is probably nice for those large customers with 1 million groups inside of their providers. You can see that this team 1, all they have access to is anything that begins with kube dash, and then we can get more sophisticated in terms of services that they have access to, or replica sets they have access to, or labels is probably the more sophisticated one, where you could say client ID equals X, and then you can have a group that matches on the same thing. So that's how we handle authentication. It is part of the enterprise subscription for Kubecost, but I figured I'd bring it up because it's been asked about more and more. From a demo perspective, I'm going to butcher my credentials again. Well, this one logged in automatically, so you don't have to watch me type in my ID. And so I've logged into an account that's restricted. And in this cluster that's saml.kubecost.xyz, you can see there's 2 namespaces, and I don't have any filters, right, in this view. If I were to log in, and let me also point out that I don't have the access to change any of the settings within the Kubecost UI. So if I were to open a new window, and I will use a different account here. One moment. So saml.kubecost.io. And this account, if I logged in with the right one, you can see I've got 8 namespaces. It's a demo environment. It doesn't have 100 namespaces because we don't want to spend thousands of dollars on fake stuff for demo environments within our lab here. But that's how it all works. And one more feature to show y'all. I think that was the agenda that we wanted to show today. If there's not much else, Sean, I'll let you figure out or decide how to handle the closure here.
Yeah, I don't see any more questions in the chat. Thanks for those that did ask questions. We always prefer to have more of a conversation than a one-sided demo. So thanks for that as well.
I guess one thing is then how could people get started? Where could they sort of go to put this all together, whether that's, whether you're enterprise or a customer, or as some of the people on the chat, first time potential user. How could they get
definitely.
started?
So Helm chart is by far and wide the easiest, especially if somebody's just getting started with Kubernetes. Think of Helm as essentially a package manager for Kubernetes. So the Helm chart's always updated with our most current release. We actually just released version 1.92.0 yesterday. A lot of performance enhancements and some bug fixes as well. So kubecost.com/install. See, we also have the Helm chart listed in the stream there as well. That'll point you to the same spot. Essentially, 1 or 2 line command to get going once you have a cluster up. I see Warrior UW there. If you just want to get started with EKS, I highly recommend EKS CTL as a command line to deploy a simple cluster without having to worry about the underlying VPC or actually configuration of EKS itself. Gets up and running. I think it takes about 15 minutes to 30 minutes depending on the instance size in the region, but super simple to get going. And it's just a matter of Helm deploying Kubecost. And then obviously if you want to see some real value, deploy some sample applications like Nginx or like the 2048 game. I'm sure there's 1,000 different examples out there as well. All of our open source repos, we happily take contributions to. We've got a pretty good community in Slack as well for anyone looking for yet another Slack workspace to join. And then, we're happily accepting pull requests as well for any of our open source repositories, feature requests, bug fixes, all that fun stuff as well.
Yeah,
I think that was going to be last question.
Is, use spot nodes. If you're just doing testing of Kubecost or whatever it is, and you don't mind the workload getting interrupted, it is a way to save costs. And I've been doing that lately as well.
Yeah, no, I mean, it's been a personal goal of mine to try to be more of a contributor to the open source community, and obviously Kubecost being one of my favorite tools, I may just have to go in and see what issues I could fix. Question about coding practices, but hopefully by the end of the year I can get something to call as a contribution here.
There you go. Yeah, we're coded in Go for anyone that likes Golang. So that's a good start.
Sounds good. Looks like there's no other questions. So with that, I think we can wrap this one up. Again, Jesse, Sean, I think it was a very informative, great session. I sure learned a lot, even though I've been personally using it in my sandbox environment. I get to get a detailed view of, not only what's provided, but how you guys think about providing these features and the reasoning behind it. So really appreciate it. Again, for those of you watching, this has been AWS Howdy Partner. As a call to action, I would highly encourage everyone to try it out. Just create an EKS cluster, like he said, with EKS Cuddle or other methods. But there are many ways to deploy an EKS cluster. Deploy some sample workloads. I don't know what my favorite is, but like you mentioned, there's a bunch out there that could create some sort of usage. Deploy Kubecost Helm chart and see what you can do with the UI. So really appreciate you guys coming on today. And with that, we're gonna wrap things up. But there is a special Howdy Partner closing that we do just to make it a little more interesting. Is we usually close off with one of our 3 phrases, and I'll let you guys be the one to choose. Kind of going with the Howdy Partner title theme. They are giddy up. So number 1 is giddy up. Number 2 is happy trails, and number 3 is see y'all next time. So which one would you prefer to sign us off with?
What are you thinking,
See y'all
Jesse?
next time, right?
There you go.
Which one?
I'm unmuted. See you all next time.
All right, so we're gonna do it in a count of 3. 3, 2, 1. See y'all next time. All right, thanks everyone. We'll be back every Wednesday, 2 to 4 p.m. Pacific time for another episode. Thank you.
Thanks, Jeong. Appreciate it.